It should have been e-commerce sessionization pipeline, but somehow we have made it as e-commerce marketing. So we'll see e-commerce sessionization. This project I will explain here because this project involves integration with Hive. It involves integration with Hive. First, we'll see how to run it in the development mode. Next time we will run it on the cluster. I will showcase how to run this on a multi-node cluster. So while we see how to run it in a development mode, I will also explain the end-to-end pipeline how it works. So here, when we run it on a cluster, we would require probably Cloudera. Then we'll be running it on Yarn. We'll be using Oozie for automation. But while running in the development mode, I will just showcase by running in the basic case. So we'll explain the code there then and there itself. I think. So what is this e-commerce sessionization? We already know what is sessionization. We have already seen here. So whether there were browser clicks, whether there were clicks continuously, or whether they were some 30 minutes apart. If the clicks were 30 minutes apart, we will say that these are all a different session ID. They belong to different session. So hence we create a new session ID for every session there. We'll see all those things by running this example. Along with that, we not only have the user clicks, we have the user clicks. Along with that, we also have sales. Sales is one data, sales.csv data we have, user clicks.csv we have. So these sales are I mean to say, just for the sake of creating this end-to-end pipeline. So I have downloaded this sales.csv and user clicks.csv. They are not related actually. This belongs to some other company. This belongs to some other company. They are not related. This is sales of something else, and this is the user clicks of some other thing. So for the sake of creating an end-to-end pipeline, in the ETL process, we will make these two related. We'll make these two related. So idea is I will just showcase how the data looks like first. So the project is in this directory: downloads, training, Spark, e-commerce marketing pipeline. So if you go to e-commerce marketing pipeline, there I have source, then main. Inside that I have resources. If you go to the resources folder, there you will see a demo data. So if I go to the demo data, so Omniture raw is nothing but it is clicks data. Omniture is the clicks. So if I go to clicks, so Omniture 0.tsv we have. So this is your data actually. So it has which page has been clicked, what is the user agent that is being used, which is the country from where the click came from, some IP address is there. We have then date and time is there. If you look at this date and time will be nowhere related to the sales date and time. So if I open the other thing, so this is our sales data. This is the invoice number. Stock code is our item code. What is that stock? Some white hanging heart, something like t-shirt. So invoice date. So invoice date, if you see, it is 2010. Invoice date is 2010. But if you see the say user clicks, it is 2012. That's what, these two data are not related. Just keep that in mind. But our use case is what all sales did happen in a particular session. We will create the sessionization, meaning we will associate user browsing to a particular session. Then what we'll do is we'll check how many sales did happen in a particular session, how many sessions did not end up any sales, how many products were sold in a particular session. So that is our goal, number of products that got sold in a particular session. But to have such a goal, the sales should have happened whenever the clicks was happened. Because these two are not related data, the what we will do is we will make this as a related data. That itself will be our ETL process. That itself will be the to showcase how the ETL process works. So what we have is from somewhere. So this is our HDFS. So here we will create tables, Hive tables. We know that Hive tables are just an interface on top of the files stored on HDFS. So here we'll create a raw table, we'll create processed table, will create a warehouse table. We will be dumping the data, our sales and clicks. Sorry, we have raw database actually. Everything is a DB, not a table. My mistake. We have raw DB, processed DB, and warehouse DB. So sales data will be, we will be dumping the sales data and the clicks data. So we have sales table and clicks table. Clicks here is nothing but our omnichar table. Omnichar is nothing but our clicks. So this data will be dumping every hour. Every hour we will be dumping here. So that there we will be creating a partition for every hour. Every hour a partition will be created. Once the partition is created, our Spark application, we have written a Spark application that will read this omnichar data. Omnichar data and process it and save it into the processed DB. Here also we'll have omnichar and sales. Here also we'll have omnichar. So what we will do here? So since these two data are not related, we will make this data related. So our first job is prepare omnichar, which will adjust the timestamp. We will adjust it to 2017. The first job will be not the first job. Actual first job is add partition to Hive table. Because on an hourly basis we will be dumping the data to our raw DB, which is sales table and omnichar table. Meaning an hourly basis, a subdirectory will be created in this directory. So that subdirectory we have to make that as a partition of our Hive table. So one job will be running to add partition to the Hive table. Your second job will be prepare omnichar data, which is our clicks. I'll just When I say prepare is nothing but adjust timestamp to 2017, because these two data is not related. We are making this data related to showcase how the ETL process looks like, just for demo purpose. Our next job will be prepare sales data. This is also a Spark job. This will be Hive job. This will be Spark. Remaining everything is Spark. So here again we have to adjust timestamp to 2017. So we'll make both as 2017, we make it as related. And we will also adjust user ID, because when we want to do sessionization and find out which user has, while clicking all the products, some user might have purchased, so the user ID should match. Again, since these two data are totally different data, so the user ID also there is no match. So if you see here customer ID, we have our customer ID. This is the customer ID. In this is our sales data, our clicks data. If you see, I think this is the customer ID, which is totally different. I think this is the user ID, which is totally different from your sales data. So that also we need to adjust, so that we can make these two data related. Make these two data related. So adjust the user ID as well. Our fourth job will be to read these two data and do the sessionization. I mean, sessionization, not sessionization, map sales to sessions. Because I forgot to say that when we read the omnichannel data, we will sessionize here itself. We'll do sessionization here itself. We'll do the sessionization here itself. Also, we'll adjust the timestamp to 2017. Since the omnichannel data is in 2017, sales data should also be in 2017. And I will also adjust the user ID, so that it matches it matches omnichannel data user ID. Now these two, after these two jobs are done, both are related data, both becomes the related data. Once you have the related data, you map sales to the sessions. So this will be our ETL. This will be our ETL process. And this is what I was trying to say here. First is prepare omnichannel data. This is our, after that we have one more, prepare sales. Again, it will save the processed data, it will save to the processed DB. Inside there will be a sales table again here. Then the third job, it will read both these two. Third job is again one more Spark job, map sales to session. Map sales to session. So it will read both the processed data. Both the processed data, which is nothing but adjustment that has been done. Then it will map sales to sessions and finally save it into the warehouse. There will DB, inside the DB we have map sessions table. So this is our ETL process. One more will be here. The very first job will be Hive job, which adds partition. We add the partition. Next we prepare, this is our first job, this is our second job, this is our third job, this is our fourth job. All these, out of that we have three Spark jobs and one Hive job. Now once we have our data in the required form, here we'll use, here from here we'll access the BI tool. As I said, Spark Shell is kind of a simple BI tool. Spark Shell is kind of a console-based BI tool, we can say. From here, we'll give the queries and showcase the uh, results. The queries could be uh, sessions which resulted in sales, sessions which did not result in sales, total products sold in a session. So such type of queries will be given on the Spark Shell. Spark Shell we can think, we can also use Zeppelin here, because Zeppelin is a also acts as a BI tool. Zeppelin, and it will be using your Spark SQL. So I hope you got the idea here. I hope you got the overall project idea. So our main goal is to get how the sessions look like, how many sales did happen in a particular session, how many sales did not happen, which were the sessions which resulted. So also you can get to know whether the particular user purchased in the first session itself or the user purchased in the second session. Such kind of things also can be given as a queries. But for to give you the for to give such queries we have to have our data mapped in this form. Sales and session has to be mapped. To map sales and sessions, we have to do all these ETL process. This is kind of a fake ETL, I can say, but it will be in this fashion only, because getting real-time data is very tough. It's very tough to get the actual data, so we have to make all these adjustments so that I can show you how an ETL looks like. So I hope the problem statement was clear and the approach that we are taking is clear. I assume it is clear since there is no acknowledgement. I assume it is clear. Okay. Now let's see how the things work. Just before we go into this end-to-end pipeline, I will just showcase, I think for the people who are unaware of Hive, I will showcase how it looks like. I'll just give a brief on the Hive architecture. So this is how the Hive architecture looks like. So we said that, so these are all our clients. We can have a PHP client, we can have a Python based web client or a Java based web client, any client can be there from where we can, I mean, just like I think I have discussed that, just like we have a MySQL server and MySQL client. So you have MySQL server and you have MySQL client. So you give the queries here actually. We know that. We give the queries here. These queries will go to the MySQL server. The server will parse it, prepare logical plan, prepare analyze, optimized plan, then physical plan. Then it will be actually processing the data, and the data will also be stored here itself. We know that this is how the MySQL works. In a similar fashion, here also we have Hive server. Here also we will have Hive client. So the default client is nothing but Beeline. Just like just like we have just like we have MySQL. This is the MySQL client, console client, where we will try to connect to the server using username something. Here the username is Kafka, password is Kafka 123. So this we have connected to the MySQL server. We are connected to the MySQL server. In a similar fashion, we have a Beeline client. We have a Beeline client. So using this Beeline client, we have to connect to the Hive server. But Hive server does not start automatically. Just like a MySQL server starts automatically, a Hive server doesn't start automatically. We haven't configured it to start during the startup. So we have to start the server first. So first we'll start the HDFS server. We'll start Yarn server because when I say we will start Hadoop, so Hadoop is nothing but the base of Hadoop is nothing but the operating system and the file system. Both has to be up and running. So our Yarn is also up and running. Now we'll start our Hive server. This is how you start your Hive server. Hive server 2, and I just want to get the logs as well. I just want to get the logs as well. Hence I'm giving this as the log. It will display the logs here itself. Hive server logs. So all the configurations has been done here. I have already done all the configurations so that MySQL is my metastore. So our Hive server is also up and running. Our Hive server is up and running. Now from the Beeline we can connect it. So the way you connect from the Beeline is there is a connect command. So this is how you connect it. This is the connect command. So Hive server always runs on the IP address, whatever IP address the system is, and port number is 10,000. Hive server always by default it runs on 10,000 port number. You can change the port number of your Hive server. So username is Kafka, password is Kafka123. So we are connected to the Hive server now. So Beeline is just a console client. Just like you can have a web-based MySQL client, you can also have a web-based Python client, PHP client, or a Java-based web client, which can all connect to your Hive server. And as I said earlier, Thrift service is the one which abstracts the cross language, whichever language client you are having. So any queries you give, so here it will compile those queries, parse those queries, then prepare plans, logical plans, then it will prepare a optimized plan, then it will prepare the physical plan. So the physical plan will be map reduce if if it is a map reduce is the processing engine configured. You can configure either MapReduce as a processing engine, or you can configure Spark as your processing engine. So based on what is configured, the optimized or the physical plan will be your MapReduce code or your Spark code. And also I had created this long back, so it is no more job tracker, it will be resource manager. It will be no more task tracker, it will be node manager. This is our Hadoop. It is an older slide, so it will be node manager. So this is our Hadoop cluster. As I said, Hive server is just an interface on top of the data stored on your HDFS file system. So from here you will be giving queries, and those queries will go to the Hive server. But to give queries, to give queries so the table should exist. To give the queries, the table should exist. So Hive is all about giving you a table kind of an interface so that the end user can give the queries. Now where will the table be created? Because because HDFS is not for creation of the table. HDFS is a file system. On the file system you only create files. On the HDFS you don't create the table. But how does Hive server give you the interface of a table now? So the actual table will be created here. So whenever in Hive you can create a table. We are connected to Hive server. Here we can create table. Now whenever you create the table, whenever you give this command, create table command here. So this command, whenever you that command will go to the Hive server. Hive server will parse that, check what is that command. So it will see that it is a create table command. So the table will be actually created in the Metastore DB. So I have configured MySQL as the Metastore DB in this image. In this image, MySQL is the Metastore DB. So the table will be created here, and that table will be mapped to the data stored in file system. Table will be mapped to the data stored in file system. So here is a question. When I created table files, no, what do you mean by table files? There will be table, then you uh, then you dump that files into that. Are you saying that files? Files should not get created. Directory will be created. Directory may get created, but not the files. Yes, because table will be mapped to a directory in the file system. Table will always be mapped to a directory. So directories will be created. Directory will be created. That's correct. Here, see, here if you create a table, say you create table, say sales, a directory will be created in the file system called sales. So what I'm trying to say here is, just for the sake of understanding, so if you say create a table, create table sales something. So by default a folder will get created in the folder, in the directory user Hive warehouse sales. Here a folder gets created and the actual table will be created in MySQL. Here we'll have our sales table. Sales table will be actually created here, and this sales table will be pointing to the data stored in this folder. We can just say this sales table is nothing but is pointing to this directory. Now whatever file we have, file 1, we can have file 2, file 3, all these files are nothing but the rows of this table. You can imagine each record will be treated as a row. Each record of these files will be treated as a row of this table. So that's how the things work. So that's the architecture of Hive here. Your table will be created in some metastore. Metastore could be MySQL or Postgres or Oracle. Here I have configured MySQL. And the table will be associated with the data stored in the HDFS. You can store the data later, or you can store the data first and then create the table, because there is no hard and fast rule that both has to be together. It is just like you are creating a variable and referencing into some file. That's all. So I hope the Hive architecture was clear. Hive architecture was clear. I think most of the people know that. Just for the people who do not know, I just wanted to give a brief on what is a Hive architecture. Now, as per our end-to-end use case, so you can download the e-commerce pipeline. It may be there in the image. It may be here in the image. Just check whether it is there. Otherwise, just download it from the Google Drive. I think the documentation is not there here. So I have the documentation in my Google Drive. If you go to the if you go to training, then Spark, inside Spark if you go to projects, inside projects if you go to e-commerce, actually it should be e-commerce sessionization, e-commerce marketing if you go. First I said that will run in the development mode. So you can go to the local mode. So in that local mode you will see this document. So this document will help you to run this program. It will help you to run this program. This guide will help you to test and run the e-commerce marketing project from IntelliJ, because we are running in the development mode. The assumptions that we are using here is using Ubuntu Linux system, Hadoop, Spark, Hive and MySQL is installed. One more assumption is Kafka is the Ubuntu username, and also Kafka is the home directory, and also Kafka home directory is created in your HDFS file system. In your HDFS file system, there will be a Kafka directory. I mean, if you have different user, make appropriate changes in the following script. We will see these scripts. We'll see these scripts. But since you are using my image, nothing needs to be changed. If you are using your own image, you may have some other user. You might have created your name as the user. So in that case, you might have to change these stuff. Kafka and Kafka 123 is the password for MySQL database, which is used as Hive metastore. You could have used, if you are using some other image, and if you have used Postgres or Oracle as your metastore and you have your different username and password, then you have to change those accordingly. As if it's your own laptop image, create appropriate username and password in MySQL. Your assumption is IntelliJ is also installed. Here you cannot, so this is not the assumption. So just a note here. You cannot automate the project using Oozie on the laptop. It requires more resources. That's the reason I will show it on a multi-node cluster. You cannot run it on a laptop. So what automation we have to do here is, as I said, this data will be dumping every hour. Every hour it has to pick the data. So we will be dumping every hour the data here. So let's say we are dumping to HDFS. So we have user, Kafka, sales. We will dump the data at, let's say 2018 04 March. Day is 25. Hour of the day is 7. So this way we will be dumping the data here. We'll create a folder, a subdirectory. Inside the sales directory, we'll create a subdirectory for each hour of the day. After 0425 underscore 8th hour of the day, a new folder will be created. 2018 04 25 09. Every hour of the day, a new folder will be created and your data will be stored here. So this is the sales that happened at the 7th hour of the day. This is the sales that happened on the 8th hour of the day. So this way. Now the Spark job have to automatically run has to automatically run as soon as this data is dumped to the file system. So you have to run the prepare omnichar data. Sorry, prepare will say omnichar data also should work, sales data at 7 o'clock. Again, prepare sales data at 8 o'clock. Again, prepare sales data at 9 o'clock. So every hour of the day, you have to run this prepare sales data. In a similar fashion, user Kafka will create a table called omnichar, and there also 2018-04-25 underscore 7 will have omnichar.csv file. 2018-04-25 underscore 8 again will have omnichar data. 2018-04-25 underscore 9 will have again omnichar data. So again we have to run prepare omnichar job, Spark job at 7 o'clock. Same thing at 8 o'clock. Same thing at 9 o'clock. And so on. And so on. So every hour of the day, all these three jobs has to run. Every hour of the day, I'm just gave that example, but at 7 o'clock, add partition job has to run. The first Hive job. Then Spark prepare omnichar. Prepare sales. Map sales to session. The same thing has to run at 8 o'clock again. At 9 o'clock, again the same job has to run. So you cannot go and run it every hour. You cannot make somebody to run these commands every hour. So it has to be automated automatically. As soon as 8 o'clock happens, all these four jobs has to run. As soon as 9 o'clock happens, all these four jobs has to run. And they have to pick the corresponding file. When it runs at 8 o'clock, so prepare sales data should pick this data only. When it runs at 9 o'clock, it has to pick this data. Similarly, when we run the prepare omnichar job, it has to, at 7 o'clock, it has to pick the data that is available for 7 o'clock. So you have to automate these stuffs. So to automate these stuffs, Oozie is being used. Oozie is being used. So that we cannot run it on a laptop because it requires more resources. Oozie requires, when you want to automate stuffs, it requires extra resources and your laptop is not capable of doing that. I will showcase that on a multi-node cluster. So you need to import this project. Just download this and import it in your Ubuntu folder. Now what is the first step here? The scripts that you want to run, the scripts that we want to run for all jobs is in the folder source main resources local mode. So if I go to that folder in the projects source folder, so if I go to the source main resources local mode. So if I go to this folder, the scripts are available to run this Spark job. Hive setup.hql, Hive setup.shell script, ingest data.shell script. So this shell script will ingest the data to the file system. This shell script will help us create the table. The very first thing is we have to create databases and the table. Only we can dump the data into that. So we have to create raw database, we have to create processed database, we have to create warehouse database. Inside that we have to create sales table, omnichar tables. All these will first create raw database and their corresponding table. We will also create processed DB and warehouse DB, but the tables will not be created because tables will be created as part of the ETL process. Initially, we only have to create a raw DB and its tables, and other database also will create, but not the tables of the other database. So here this script will help us. So if I open this script, let's see what this script has. Hive setup.sh. So there we are actually running Hive setup.hql. So this is how you run a HQL script. Here as of now this is not being used, but actually this is how it should be used. This is how it should be used. Let's not worry about this as of now. Let's not worry. So in the shell script, we are just calling our Hive setup.hql. Our Hive script we are calling. So let's see what is our Hive script first. Hive HQL. So as you can see here, we are creating our database. Create database if not exist raw. Create database if not exist processed. Create database if not exist warehouse. All the three databases we are creating. Once we create the database, we'll create omnichar logs table. We'll create the omnichar logs table. Now if you see the data here, so this is our data. Actually this data has around 175 fields, columns. This data has around 175 columns. Hence, hence we are, hence if you see there will be created. So we are creating 175, 178 columns actually. There exist 178 columns. Hence we are creating 178 columns. But we don't need all the 178 columns. We only need few of the columns. So here we are creating a table and we are partitioning it by date underscore date. Date is timestamp. So we are partitioning it by timestamp, meaning every hour of the day. So when we say partition by hour of the day, a subfolder will be created. Here partition references a subdirectory in your table. When I say table, table is mapped to a directory in the file system. Table is always mapped to a directory in a file system. Partition will be a subdirectory in that table directory. So that's the so we are partitioning it by timestamp, that is every hour of the day, so that we can make make this will be our one partition. This will be your partition. This will be a partition, a subdirectory. These are all your partitions. And we are saying that we are saying that the data will be stored here. The table, we know that table will be created in the meta store, that is actual MySQL, but that has to map to the data stored in file system. So it will be mapped to the data stored in this location. Data will be stored in this location. Similarly, now since we don't need all the 178 columns or all the 178 fields, we are creating a view. Create view if not exist as raw omnichar. Raw is the database name because we have already created. Raw is the database name. Inside that database, we are creating omnichar logs, which has 178 columns. Since we don't need those many columns, we'll create a view on this table. And the view name is omnichar. So where we use only column 2, column 8, column 2 is timestamp, column 8 is IP, column 13 is URL, and so on. And we'll also put our date TS from raw.omnichar logs. In a similar fashion, in a similar fashion, we'll also create sales table. Inside the raw database, we'll also create the sales table. Sales table has invoice number, stock code. It has to be the same. Whatever we have in the data, the same it has to be here also. So whatever field name you have here, the same field name we have to specify while creating the table. And it should be in the same order. So you should not mismatch the order also. If invoice ID is the first field, here also it should be the first column. Similarly, here also we are making date underscore ts as the partition, so that all these becomes a partition, so that only a particular partition could be read. So these will be your partitions, so that only a particular partition is read at a particular time. Not all the data need not be read. So when you are running it on at 7 o'clock, you read the data from the partition, this underscore 7 partition you read. When you run the job at 8 o'clock, you read only the _8 partition data. You need not read all the data from the table. You only read the required data. That's the reason we need partitions. So what I will do is I will delete all the stuffs. We'll start from the scratch here. So this is our file system. We know that we can browse this file system. User, Kafka is the home user in our case, and we have our e-commerce marketing. So what I will do is I will delete this. I will delete everything from. So we know that we can only delete it from the command line, or if you are using Cloudera distribution, Cloudera provides you a Hue interface through which you can delete. But if you are using your own distribution, then command line is the only way you can modify the file system. So Hadoop fs minus rm minus r, I will minus say minus skip trash and give the path and give the path. It will delete the anything that is there in the e-commerce marketing. The whole e-commerce marketing folder is deleted. So we can check now. It says please check the path because that folder is deleted now. Now as of now nothing exists. As of now nothing exists. So if we also go to Hive warehouse, so we'll also delete this processed DB, raw DB, and warehouse DB. All these things will delete. Hadoop fs minus rm minus r minus skip trash. We can delete everything. User Hive warehouse. I mean that's the default directory of Hive. This is the default directory of Hive. Inside that we have we have this was earlier created raw.db. Anyway, these are being deleted. Just I wanted to show how to delete it. Warehouse.db. Right. So nothing is there as of now. It is from the scratch now. We don't have anything in our HDFS. The very first thing that we will do is we will create the tables. Now all those create command we have specified in a shell script. So that shell script is in the folder local mode I said. So we have to just run this shell script. So it will create all the three DBs, all the three DBs, and two tables in the raw DB, two tables in the raw DB. As of now, all the things is deleted. So we don't have any DBs here. Now let's create the DB. So you have to just run hive setup.sh. That's all. Nothing has to be done. So all the so it has given okay for everything. We can go and check once again now. So if I refresh this warehouse, so we can see that raw DB has been created, warehouse DB has been created, process DB has been created. So when we create a DB, actually a folder directory gets created in the warehouse. This is the default path. This will be configured while installing Hive. While we install Hive, this will be configured. That's the default path. So any database you create, any table you create, a subdirectory will be created in this warehouse directory. So since I have created raw DB, a subdirectory by name raw.db will be created. Similarly, processed.db subdirectory is created. Similarly, warehouse.db subdirectory will be created. So if I go inside that, in this nothing is there. Nothing is there. Later, when you create a table inside the inside this DB, a subdirectory will get created here. A subdirectory will get created. For every table, a subdirectory. Here also we don't have, but we have already created table in the raw. So that table, I think it will not show here because we have given the location. So if we go to the yeah, if you see here, we are creating omnichar logs table, but while creating the table, we are saying map it to the location. If we don't specify mapping it to the location, it will create that directory inside that DB directory itself. But here we are saying map it to the location, this Kafka e-commerce marketing data raw omnichar. So this is your omnichar table now. The table is mapped to this folder. Sorry. So let's go and see. Probably it may be there or may not be there. I'm not sure. If I go to Kafka, so here e-commerce marketing folder, data folder, raw folder. So as you can see, this omnichar folder is created and your sales folder is created. Because that's how we have mapped it. We want our data to be dumped at this location. As a result, we will create the table referring that location. Our table will be referring that location because we want our data to be dumped in this location. Now the table everything is created. So that should show in our Beeline client. So this is our Beeline client, right? I mean, we created the table So here we can say in our beeline client, just like we say show tables in MySQL clients, here also we can say show tables. So by default it shows the tables in a default DB. So default DB. So if I say show databases, processed is 1 DB, raw is 1 DB, warehouse is the other DB. 3 DBs we created. By default there exists a database by name default. So it will show the tables in that default. Whenever we say show tables, by default it shows whatever tables is in this DB. So you can use now raw, you can use raw. Inside raw you can say show tables. So we know that we have omnichar logs table, we have our sales table, and omnichar is our view. So it shows all the tables that is available in the raw database. So if I do select, it is just like your MySQL client. We have our beeline client. Select star from omnichar. So we have all these columns: timestamp column, IP, URL, user ID. But the data does not exist because because we did not ingest any data here. We did not ingest any data to our file system. There does not exist any data. If you put some data here, if you put some data here, it will give the result. I mean to say, let me showcase. Just for understanding purpose, let me manually copy without running the script. Let me manually copy here. Let me go to the demo data in the resource folder. Let me go to the Omnichar raw. Let me just say Hadoop fs minus put. Hadoop fs minus put the data to the HDFS file system. Which data? Omnichar 0.tsv to which path? Put this to this path. Just for the understanding purpose, we should not do this. I'm just showcasing how it looks like. So we have copied the data. It should be available in this folder. So we have our data available now. Our file is available now, and the table is also created pointing to this location. So any data in this location will be the rows of your table. Will be just like the rows of your table. Any files. So if I rerun this, I will just limit by 10. Okay, so it will. So it is showing some. No, it doesn't show anything, right? Column 1, column 2, column 3. So the idea is this, because we have created the table as a partition table. So it looks for some partition. It is looking for some partition. So only then it will showcase. Only then it will showcase. So my mistake, I shouldn't have given this command. So let's delete that data. We will insert the data in a proper fashion. Fs minus r fm minus r minus skip trash and specify the path. Here is a question. The question is skip trash will permanently delete from the HDFS file system. Otherwise, that file system also has a trash like recycle bin. It will put there, and after some time it will remove from the trash. Skip means it will permanently delete it. So here the white is showing no such file or directory. Why it copied two times actually. So we deleted omniture0.tsp. Just forget this step. Forget this step. So we'll ingest it in a proper manner. We'll ingest it in a proper manner. Let's see how that ingestion script looks like. All the scripts, as I said, is in the local mode. So this is our ingest data. So if I go to ingestdata.sh, so this is our script. Our name node is this. We know that our name node is running on 9000 port. Localhost name node should be, I said that name node is a daemon. That daemon should be running on some IP address and the port. The IP address and the port is this. Since I'm running on my local laptop, the IP address will be the local host. The port number I have configured it to run on 9000. Our project path is this. Name node service, user Kafka, and this is our project. Now where the data will be copied, the data will be copied in the project path. We'll have our data folder, raw folder, omniture folder, and we will create a timestamp. So here we are creating, as you can see, the timestamp. This is a shell way of creating a timestamp. Our timestamp should be in this format: year, month, day, underscore r. So we get the timestamp, and that timestamp will be created as a folder. So every time at if you run this command at 9 o'clock, a folder with underscore 9 will be created. If you run this shell script at 10 o'clock, underscore 10 folder will be created. If you run this at 11 o'clock, underscore 11 folder will be created. So that's our Hadoop Omniture data directory. Similarly, we are creating Hadoop sales data directory in a similar fashion. Only thing is data raw sales is the path. Inside that a folder will be created. So then we copy our omniture data to our sales data. Sorry, then we copy the omniture data from our local laptop file system to the HDFS file system. The put command, the same put command that I used. So that will be putting the data from the local file system to the HDFS file system. So this is our local directory. This is our HDFS directory. This is the local directory where the sales.csv exists, and this is the HDFS directory where we want to put the put the sales dot data. So we have to just run this script and specify the omnichar path and the local omnichar path directory and the local sales path. So that's how you have to run this script. So we'll say ingest, we'll run this ingest raw data.sh, and we have to specify the path of our data. So our data exists in demo data folder. So there we have omnichar. We'll copy this omnichar.csv. Also we have to specify our sales data. So this is how you run this ingest command. When you run this ingest command, it will take this omnichar data and it will take this sales data and it will copy it to the HDFS corresponding directory. So let's run this and check the result. So as of now, nothing is there in the omnichar directory. As of now, nothing is there in the sales directory. So let's run this command. So as you can see here, timestamp has been created as _8 because it is 8 o'clock now. Because it is 8 o'clock, a timestamp has been. So this a folder or a directory with this name will be created in the HDFS, and data will be stored there. Data will be stored there. So omnichar data has been copied there, and our sales data has also been copied. So if we check here now, we have our sales data. A folder and subdirectory has been created with _8, and inside that we have our omnichar.0.tsv. Similarly, we have created our sales. Under sales _8 folder subdirectory has been created, and online retail sales has been copied. So data ingestion is over. So this such kind of a ingestion will happen every hour of the day. So usually this script should also be run using some cron tab, Linux cron tab process. So every hour of the day this script should be running. So somewhere in your server some data will be existing. This is some server. Your client has dumped the data here. Your client will be dumping the data here to some server. So here you have to run this ingest data. You have to run the ingest data every hour. So this should be some part of a shell script, cron tab shell script. Cron job they say, I think. I don't know what they say. Cron tab some shell script. So every hour of the day you should be running this shell script, ingest data. So it will be copying the corresponding hour of the day to the raw table, raw DB inside that sales table and the omnichar table. So I will just finish this one part, then we'll see the Spark job we'll see tomorrow. So let's see whether we are able to query this. So we have ingested the data. Let's check whether we can query this. So still we are not able to see the data. Let's check with the sales table again. Even though we ingested the data, we are still not able to see the data. The reason is this, because we have defined our table to be a partition table. We have defined our table to be a partition table and partition by timestamp. But Hive by default does not understand a subdirectory. So we created a table for this location, and the table is referring to this location. Hive does not understand any subdirectory inside the table directory. This is our table directory, and Hive does not understand any subdirectory unless you explicitly say that this subdirectory is the new partition. Unless we have to, I mean, we have to explicitly say that this subdirectory that is created is your partition. So Hive does not understand any subdirectory in the table directory. Now we have to explicitly say that this is your partition, the subdirectory that is created. Now how do we say that this is a partition? So we have to add a command. We have to run a command called add partition. So that is, if you go here, so we have done all these steps. In the step 1 we have created the table. So we have already started all these steps, and we have run the hive setup.sh. Our next step, we have also ingested the data. So we got all these directories, similar kind of a directories, but based on the timestamp. The next step is nothing but creating a partition. So this is how you say that that new subdirectory that is created is your partition. So this is how you have to say that. Because Hive does not understand the subdirectory in the table directory, you have to explicitly say that this new directory that is created is the partition, is your partition. So the command is alter table raw omnichar add if not exist partition. Our partition column was date ts. This is what we had defined while creating the table. So the partition will be now, this will be our, sorry. So this will be the partition. This directory will be the partition, and that's what we have to specify here. And we have to say that the corresponding path is our partition. Correct. This we are doing manually. We have to do it manually here. So when I showcase, but when this has to run every hour. So this we will put it as a one of the job in our Oozie. That's what I was trying to say. So when we do it using Oozie, all these jobs has to be automated. So it will correspondingly add the current timestamp as the partition. While we run it in Oozie, so this will be done dynamically. Because we are running in a local mode, we are doing it manually. Otherwise, we have to do in the, I will showcase that when we run these things, automate all these things. So it will pick up the the partition automatically. That I will showcase. Similarly, this is only for local mode, for testing in the local mode. So first you have to run this command. So that partition has been added to the omnichar. Let's Let's see the omniture. So as you can see here, now we got all the data. So from the Hive, we are able to query the data. Select star from omniture. It will actually pick up the records from that file as the rows. Records from the files will be treated as the rows. Similarly, we have to do it for the sales also. Because if I again say for sales, it will not show, because in sales also there is a subdirectory created, and Hive by default will not understand the subdirectory. So again we have to add the same thing. So we will say raw sales, the same path will be the same. Here user e-commerce marketing raw, and here it will be sales. Path will be sales. Give this command once again here. So it will add that newly created subdirectory as a partition. So now you can give the query. Select star from sales limit 10. As you can see, now you are able to see the result. But here I'm adding these partitions manually. Now again at 9 o'clock, I should not go and add this partition manually. Again at 10 o'clock, I should not run this command. So this command I should not run every hour of the day. It has to be automated. So that's the reason that will be the first job when you are doing the automation. Add partition will be your first job. As soon as you dump the 9 o'clock folder is created _7, this job will run, which will automate. As soon as you dump the data at 8 o'clock, _8 folder will be created. So then add partition will add that newly created folder as the new partition. So these things will be automated. Once the partition is created, we will run the Spark job, which will read only the 7 o'clock's data. Similarly, when we run it at 8 o'clock, the Spark prepare omniture will run and only pick the data from 8 o'clock's partition. Similarly, it will pick from 9 o'clock's partition when it will be running at 9 o'clock. So we'll see that. We'll see the next what has to be done tomorrow. Here is a question. Here is a question. In Hive, is it that always we can add new change data? I mean, is there update of say existing data? You can do the update, but I think it is only supported for ORC file format. Not everything supports update, only ORC file format supports update. And I haven't used that update, but you can find the blog where you can see the update. So there is something called as transactions. Some settings has to be done, and your file has to be not the CSV file or a TSV file. Your file has to be a ORC file format. You cannot update on these files. .csv you cannot, nor JSON. Java class files. I am not sure on that. Not sure on that, Samir. But ORC file format has to be used. Okay. So let's wind up the session here, and let's continue tomorrow. Tomorrow we'll see the Spark, how it integrates with the Hive, because our data exists in the Hive now. Now we have to run the Spark job, which will read the data from Hive table and do the processing, which is adjusting the timestamp and doing the sessionization. Thanks everybody, and have a nice day. Others, good night. Thank you.